Again, before the break happened, if you guys are like me, hopefully you shut down completely as far as this class and didn't do any studying or prep work that you shouldn't have. So I put 2 questions on the board here. Here's the information prompt, and then these are the 2 questions. So if you got a piece of paper or at least a calculator and you want to try to get these and see what you get, we'll talk about these, how to set this up, just kind of do a quick refresher of some of the probability we discussed a little bit last semester. And then the nice thing is this semester's probability is a lot more systematic. There's always like a pattern to the one we're going to do this semester, whereas last semester was kind of all over the place. So some of you guys might find this probability easier. Others may not like it as much as the other one because you guys did really well on it. So anyways, we'll start talking about all the new stuff tomorrow. Again, I just wanted to kind of warm you guys up a little bit about what we were talking about in class before I hit you guys tomorrow with the new stuff. So anyways, take a minute or two, see if you remember how to do this. You may not, and that's okay. Like I said, I'm not going to grade it. So play with it a little bit, see what you get. I'm going to take attendance while you guys are doing it. Good morning, guys. How's it going? I'm just mentally torturing you guys on your first day back and seeing what you remember from last semester. So. No, nothing, exactly. It's not for a grade or anything. Just feel free to grab a calculator or a piece of paper and see if you can remember how to do this. And say for those of you guys just came in, we're not going to start anything fresh, new, or anything that's going to be required for grade until tomorrow because B day is our official learn day, and then A day is our official work day. So. No, today would be an A day. So we're actually starting off semi-normal on the schedule. Today is an A day. So you have first, second, third, and fourth period classes today. And of course, eighth period if you are unlucky enough to have both. All right, so I'll give you guys a couple more minutes to think about this one. If you can't read it, I'll read it real quick. Certain city has 43% of married teenagers which have children, and 19% of unmarried teenagers have no children. Sorry. Hope if I put everything in it earlier. Oh, I'm sorry. I did right there. G waking up to that was correct. 19% of unmarried children have 19% of unmarried teenagers have children. 8% of the teenagers in general in the city are married. So there's two questions. If a teenager does have a child, what is the probability that they are not married? All right, so this is one of those conditional probabilities. I don't know if that'll help or not as far as a clue on that one. And then letter B, what is the probability a teenager does have a child in general? So a couple different ways you can set this one up. I'll let you guys think about it for another minute or two, see what you get, and then I'll show you guys how I would set it up, how we talked about in class, and then we'll go about solving these. And like I said, this is just a review. If you forgot most of the stuff, it's okay. It's not required that you know it today. You've got a couple of days, obviously, to get back into the swing of things and warm back up again. So, and we do a long, at least a couple week long review in April, getting ready for the AP exam, so that you guys will be prepared for that as much as possible. So did you see the meme, Cole, where it says Jason Garrett still keeping the Cowboys out of the playoffs? They're making fun of it on the radio the other day, like this team still had a chance mathematically on the last day of the season still.
Yeah. You see what happened during the game that cost us. All that really happened is there was play that New York ran, and it was an incomplete pass, and it was pretty blatantly obvious, at least in my opinion.
Right.
And Mike McCarthy didn't challenge it for being called complete, and they ended up scoring a field goal, which gave them the go-ahead lead. They won. And some people were pissed that Mike McCarthy didn't challenge.
Yeah, sorry, sir. There you go. I'm gonna make it easier for you. Yeah, I don't know. Everybody said that his first year in Green Bay was a little rough too, so we'll see.
I would hope by the time he's at least somewhere else that he was a little bit better.
Yeah, I just added. I don't know. When I hired him, it sounded like a good idea at the time, but then you know, that's the way the season played out. I don't know. It's hard to say if it was the long-term injuries or if it was the bad coaching, because there was a lot, especially at the beginning of the season, a lot of grumping going on about how the coaches were just confusing. And but then you look back and like, you guys had like 10 years of Garrett. Like any coach coming in should be a lot more clear and easier to understand than dealing with him. So I don't know. All right, take about 2 more minutes. Just look at these. Like I say, if you don't remember, it's okay. We'll just kind of review and warming up a little bit. Tomorrow we'll start our next unit number 5 on probability. We'll get to use the calculators programs a lot more, so hopefully we'll be a lot more systematic than what the first one was. Everybody have a good break, I hope, for the most part. Didn't work too hard. Emily, looking at you, didn't work too hard. That's good. Don't worry about you guys working too hard. You're still young yet. Well, I mean, it's okay to work hard, but not to the point where you're like, you know, some of you guys put in like 35-hour work weeks, have 4 AP classes plus football. It's like, all right, you can still be a kid a little bit. Got a guy that's like that in my 5th period class. He's got like 5 or 6 AP classes. He does football, track, has a job. I'm like, dude, like, do you have any time to just be stupid and do something, you know, fun? He's like, no. You got to have a little bit of time to do it. You know, not too much, but a little bit of time to do that. Because once you become an adult, then you have even less time to do that stuff. All right, so let's talk about these. Again, if you don't remember, it's okay. I set mine up using one of our nice tree diagrams here. That's the easiest way to set this up because you can split things into an either or situation, and then there's 2 branches after that. So if we read the prompt here, we say that a certain city, 43% of married teenagers have children and 19% of unmarried teenagers have children. And then the most important part is the very last word, 8% of teenagers in the city are married. So you go up here and you divide them up between married and unmarried. So this is 8% and 92%. And they say, okay, of the married ones, we got 43% with children and then 57% without. And then with the not married ones, which are the remaining ones here, then you have 19% of unmarried teenagers have children, and that leaves you with 81% without children. So that's the way I set it up. Now, for the first question, it just asks you if a teenager does have a child, which is only these two spots, what is the probability that they are not married? So basically, if you can figure out whatever these two are when you multiply them and whatever these two are when you multiply them and add them up, that would be your final answer. So that's what we'll do real quick. All right, so 0.08 for the 8% times the 0.43. All right, that's going to give me 0.0344. And then for down here, the unmarried children, or the unmarried teenagers, sorry, with children is going to be 0.92 times 0.19. That's going to give me 0.1748. And again, you can just add these together and that'll be your final answer. Now, there are two more percentages here that you could do and then add all four up to make sure they get one if you want to make sure you're doing this right. I did not do it. I'm taking a chance. All right, but that would be your final answer. So 0.2092. All right, so about 21% is the answer that we got for that one. Again, it's just a review, not putting anything up for, no, you're good there. Just reviewing a little bit, just seeing if your brain remembers anything at all from last semester. No big deal if it doesn't. Maybe some of this will jog your memory a little bit. We have the extra day here in zero period because we don't start anything new until B day. So for those of you guys that just got here, don't stress yet. All right, what is the probability a teenager does have a child? So what is the probability a teenager does have a child? And then again, all you got to do is look at the ones where they're children and just add them straight up because this is not children here and not children here. So it's got to be pretty much the same setup here as far as using your tree diagram and going through it that way. All right, so I'm going to go ahead and just figure out these numbers real quick. Probability a teenager does have a child. I feel like it should be the not a child. I probably wrote it down wrong. So for this one, it's 0.08 times 0.57 because I want to find out these numbers, 0.0456. And then for down here, 0.92 times 0.81. What's up, Will? How you doing? It's okay, man. You're not missing anything important. We'll just review. All right, so if I add all those up, I should get one, and then we can go back through and whatchamacallit, we can answer letter B. Okay, so I didn't answer letter A all the way. I apologize, I didn't read the last part. If a teenager does have a child, what is the probability that they are not married? So we have the denominator part where they do have a child. We got to put the not married one on top of that one. So I forgot my last part there, sorry. So of the two numbers that we got on the last one with the child, 0.0344 and 0.1748, that was our denominator. Which one of these two is the not married one? And that's going to be this one here. So our final answer should be 0.1748 over 0.2092. This will give us our final answer for this one. And I'll explain why in just a second. Why my brain's not 100% warmed up yet. So 0.8356. All right, so on this one, I just answered the first part of the question. If a teenager has a child, that's this percentage right here, which is really our answer down here. What is the probability that they are not married? So of all of the teenagers that have children, how many of them, or what is the percentage of them that are not married? So that's where when you go back, okay, these are your two children categories. So we add those up to be the denominator. These two numbers here would go down here in the denominator. And then of these two numbers, which one comes from the not married one? This one here, right, is on the branch with the not married. So that's the number that would go up there on top. And so there's where my fraction is. And that would be my final answer out of that. And then what is the probability a teenager does have a child? That's just straight up what we figured out earlier. So I had the wrong answer on the wrong one. So I probably just confused the heck out of you. But overall, anybody kind of remember this a little bit? Not so much? Okay. So it doesn't always come out and say, hey, draw a tree diagram and solve this. Sometimes it's just one of these questions with nothing on there and it's very confusing. So if you can see one or the other type of option, give it a tree diagram chance and see what's going on. Okay, one more just to torture you a little bit and then we'll call it the morning. Like I said, we're just reviewing here to get you guys warmed up. So this last one here says 2 dice are rolled. What is the probability that exactly one of them, so this is kind of your clue here, lands on a 5? Preston, what's up, man? It's good to see you again. I'm doing good, man. Life been treating you okay? All right, 2 dice are rolled. What is the probability exactly one of them lands on a 5? And for this problem, we're assuming a traditional, fair, weighted, 6-sided die. All right, so we have 2 dice that we're going to roll. We want one of them for sure to land exactly on a 5. On the other one, it can be anything else. It can be a 1, it could be a 2, it could be a 3, it could be a 4, it could be a 6. We don't care. So break these down into 2 separate probabilities. Yes, it's happening at the same time, so we'll multiply them together. And then we'll discuss what else we're supposed to do afterwards. So what is the chance that any single die lands on a 5? What are my odds of that happening? Just rolling one single dice, roll it, and it lands on a 5. What are the chances of that happening? 1 out of 6, right? Because we've got 6 equal sides. So the first blank is going to be 1 over 6. What is the chance then that the other dice is anything but a 5? We now have 5 options left out of 6. Very good. Now, this is one possible scenario. Okay, when it comes to exactly 1, you can have the first one be a 5 and the second one be something else. Or you can have the first one be the other and the second one be exactly the 5. So you can solve this by multiplying these together and timesing it by 2. That's the shortcut we talked about back in December because there's 2 options here that can happen. If you were rolling 4 dice and you were asking for exactly 1 5, then it would be 1 out of 6 and then 3 of these. And then you would multiply that by 4 because there's 4 different dice. So whenever you see the exactly 1 problem, you either add up all of the different possibilities, or the simple shortcut that we talked about in December was to multiply by how many different options you have. So in this case, I'll show you both on the calculator just so you guys can see how that still works. So we have 1 out of 6 for the first die, and then we have 5 out of 6 for the second die, plus we're going to have 5 out of 6 for the first die again, it could be anything, and then 1 out of 6 for the second die. What do we notice about the 2 numbers? They're always going to be the same. So that's why you can multiply into the shortcut. So it's this number plus this number. All right, so the actual final answer is 0.277777 on lots of 7s until you get to the 8. So 0.2778. All right. And so again, you can just, on the ones with just 2, it's easy enough just to add it. But let's say that we were rolling, 5 dice, and I want exactly one of them to be a 5. Well, all of these other ones would just be whatever else that's not a 5. All right, and so my fractions would be this right here, but I would have an additional 3 of these that are 5 out of 6. All right, and so this would just be one possibility here. If I didn't want to rewrite this 5 more times, because the 1 out of 5 can shift any spot, then I could just take the answer for this and times it by how many are there. Because again, we're going to get the same answer each time as we go through and multiply these things. Anyways, just a little bit of probability review, nothing major, nothing fancy. I just wanted you guys to kind of remember some of the stuff we talked about a little bit back in December, because I know if you guys were like me, you didn't do anything on the break and you shouldn't have, and that's good. Let me show you real quick the module that we have for this unit here. If you guys at home would like to print off stuff, I'll show you where it's located. Those of you guys that are my in-person people, I've already made copies of this stuff. So unless you want your own fancy copy for whatever reason, then don't feel like you have to print these things off. So the new module is uploaded. We're going to be talking about discrete and continuous distributions. So you should remember these words from way back in September. Discrete means we count things. Continuous means we measure them, or there's lots of in between. So we're going to talk about probabilities dealing with those types of scenarios. There's an outline for the notes. There's a homework packet, a supplemental packet, and an FRQ packet. So I have all of these from my in-person people already copied. That's what I did yesterday. So you guys that are in class don't have to worry about printing one off if you want one. Those of you guys at home, if you would like to print these off, I just wanted to give you guys plenty of time to do so. If you can only do a couple at a time because you have limited paper, then definitely start with the notes and maybe the homework packet. These two things will happen a little bit later in the unit, so you can wait a couple days before you do those if you need to. The neat thing is this unit, I was looking, and the book problems out of the textbook this time are optional. So you don't have to stress and do those this time. They will be there for extra practice. So that'll be nice as we get back into it. Anyways, everything is already set up in Canvas, so feel free to explore and get into trouble however you want. Those of you guys at home, there's your attendance checks here at the bottom for today. Today is January 5th. So make sure you're keeping up with those so I have documentation of your existence and get you guys the attendance that you earned by showing up today. That's all I got. Like I said, short, sweet, simple. Just a quick review, and I welcome back to make sure you guys are good on everything. Questions or anything for me before I sign off for the day?